Okay, we're moving on to the statistics portion, the regression, and I think we gave you an ogive curve. Before I go there, let me just fix my previous answer. I said this was x equals positive 2, but clearly it's x plus 2 minus 1 is x plus 3 is x plus 2, goes over, becomes a minus 2. Okay, so just to correct that. Our next question is a question 5, which says the following. A manufacturer of a dishwasher wants to determine if there's any relationship between the monthly sales, which is given to you in hundreds of units, which is this, Y, and the number of television advertisements per month, which is X. Okay? They tell us this is the data they've collected, and then they were kind enough to give us a scatter plot of sales against advertisements. Okay, so let's have a look. Now they ask us for the standard deviation of the number of sales per month. The number of sales per month is the Y variable. Don't make a mistake and work out the standard deviation for X. That's for the number of advertisements. Okay, to remind you, how do we do this? We're going to go to our calculator and say, good, mode, I want stat, I want single variable analysis, which is 1. Now I'm going to plug in all the sales data. So I plug in 8.4, I press equal. 5.2, I press equal. 7.1 equal. 10.0 equal. 12.9 equal. 11.5 equal. 14.4 equal. 13.5 equal. 8 data items, all clear. Now I go, the important part. Okay, I'm going to go and I'm going to say shift stat here. Then I have all those options. I'm going to choose option 4 over there. Okay, and then after that I want the standard deviation, so I'm choosing option 3. And I press equal, I get 3.0650. So 3,065. Now remember we said correct to 2 decimals. So this here is 3,07 for 2 marks, correct to 2 decimal places. That's your standard deviation. Okay, for 2 marks. 2 marks because you had to do a bit of work. Okay, now we want to write down the regression equation. Okay, so we go back. So we're still in stat mode. Okay, so let's just check. Yeah, we're in stat. Now we're going to do 2 variable analysis, A plus BX. So you're looking for Y is A plus BX. Now remember, A is the y-intercept, B is the gradient of the line. So we choose number 2. It gives us the table where we can now put in our values. We start with X. So 11 equal 6 equal 8 equal 9 equal 12 equal 15 equal 14 equal and 13 equal. Go to your Y column. 8.4 equal 5.2 equal 7.1 equal 10 equal 12.9 equal 11.5 equal over there 14.4 equal and 13.5 equal. Okay, we've got all the data in the calculator, so we're all clear. Now we go shift stat. We want to go to our regression equation, which is number 5. There's A, there's B, and here, by the way, is your value for your correlation coefficient. So let's find one first. A is equal to, okay, so A 0.377941. I'm leaving it there for now. We'll come back and fix it. We go all clear. We go back shift stat. We're still looking at regression, and now we want number 2, which is B, and B is equal to 0.908823. So with that information here, correct to 2 decimal places, Y will equal 0.38 plus b, which is 0.91. This 8 goes to 1x. And that was for 3 marks. Your regression equation, you should get full marks for this, because the calculator does all the work. You just have to make sure you put in the right values in the calculator. Okay, so let's have a look here. We're now going to draw the regression line on this scatter plot. Show any critical points. Now the critical point, folks, is the point of means that you need to calculate. It's the mean for the x and the mean values for the y's. Okay, so let us see. If I go, sorry, and I want to clear this mode, I'm just going to go comp. There we go. So what I'm going to do, the quick one, is I'm going to add all of that and just divide it by 8. Okay, that gives me the mean for x. So 11 plus 6 plus 8 plus 9 plus 12 plus 15 plus 14 plus 13 gives me a total of 88 over there, and 88 divided by 8 means the mean is 8. 8.4 plus 5.2 plus 7.1 plus 10 plus 12.9 plus 11.5 plus 14.4 plus 13.5 gives us a total of 83, and 83 divided by the 8 data items gives us 10,375 as my y value for my point of means. Okay, now I'm going to draw this on my set of axes. I need to indicate my point of means. So my x value is 11. 11 lies more or less here in the middle. I'm just going to put a black line up there. There's my 11 line. My y value is 10,375. So there's 10, there's 11 up there. So 10,375 is more or less over there. A little bit lower. So I'm going to draw it there, and I'm going to say that is my point, 11. And we said correct to 2 decimal places. So I'm just going to say this is 10,38, my point of means there. Now what I also know is I know the y-intercept. The y-intercept here is 0.38. Now what that does nicely, remember your regression line has to pass through your point of means. There's 1, there's a half, just underneath it more or less is where the y-intercept is going to lie. Okay, so if I draw, I'm going to draw my line in pink. There's my regression equation. Just take it past or to the last data item. There we go. Okay, and this here is 0.38. Now if you look carefully, folks, this is so beautiful, because what it does now is it actually does put an equal amount of points at the top of the line than what there is on the bottom of the line. It shows the point of means, and also this y-intercept is the one that directed the line. Now we have the y-intercept, so use it. It makes your graph so much more accurate. You're not going to use this for prediction on this side or bigger than the 15. We're not going to do that, and we'll talk about that just now. But our line is perfectly directed. Okay, so this here was 11, 10,38, and the y-intercept we've got. Now calculate the correlation coefficient of your data. Okay, so we go back, and I've now cleared. I can't believe I've cleared this. Okay, so I've got to go back and go mode, stat, and I've got to go to variable analysis. Oh my goodness, and I've got to put all of this in again, but it's going to go quick, so let's do it. 11, enter, 6 equal, 8 equal, 9 equal, 12 equal, 15 equal, 14 equal, 13 equal. I should have actually written all of those down before I went and cleared everything. Okay, so 8.4 equal, 5.2 equal, 7.1 equal, 10 equal, 12.9 equal, 11.5 equal, 14.4 equal, and 13.5 equal. All clear. I go shift, stat, I go to regression analysis, which is 5, and I tell them number 3, I want the regression, or the correlation coefficient. Okay, and that's 0.86 is my correlation coefficient, correct to 2 decimal places. 0.86, and that got you a mark. Okay, now let's comment on the trend in the data. If I look at the data, these data items lie close to the regression line, so it's a rather strong relationship, which is confirmed by the correlation coefficient. So if I say the word strong, I'm correct. What else? Well, the gradient is positive. It's a positive slope. The increase in advertisements definitely had an increase in sales. So it is a strong, positive, linear trend in our data. Okay, that's it for number F. For number E. Sorry, that was my phone. If I go to number F, over here, now they ask us to predict the number of sales in a month if 25 television advertisements were shown. Let me just... Okay, we're looking at the 25 television advertisements. Okay, let's go back to the data. The data, number of advertisements, has a maximum of 15 and there was a minimum of 6. Now 25 advertisements lie way outside of this data. Okay, so it's not a good idea to try and predict using our model what it would have happened if it was 25. Had the question been 10, okay, 10 is over there, or 7 advertisements, or even where can I look at here, 13, we've got the point 13, then the trend line will help us to predict the sales. But with the 25 advertisements, it's way out of the range of the data. So we're extrapolating here, and we're extrapolating way out of the data. So we cannot predict accurately what the sales would be if 25 ads were shown. Why not? Since that would mean extrapolation far from the range in the data. Okay, that's a mouthful. But the key thing here is 25 lies outside of the range, which means you're extrapolating, not a good model then to use to do that with. Okay, that was question 5, folks. Sorry for the interruption, but I hope that helped you. The last question will be question 6, and we'll look at it just now.